Today we work in a multi-CAD world, challenged to import and often edit data, regardless of what software created it. Take this example, a chassis design where we need to import 3D supplier data from various sources and make edits where needed. First of all, let's take a look at importing the 3D data. Well, actually forget import. All we need to do in Solid Edge is simply open, like you would any other file. You can see here the many file types Solid Edge can open, files from other Siemens software such as NX, universal CAD formats such as Parasolid, Step, IGES, and even files from other CAD systems such as Inventor, Pro Engineer or Creo, SolidWorks. SolidWorks. The first component we need to work on is from that system, so let's open that right up. Now it's easy to forget that this is a non-Solid Edge part, as we can work with it in exactly the same way we'd work with a native Solid Edge file. For example, specifying what material it's made out of to get the correct weight, or applying a colour or finish, nice and easy. Really though, the challenge comes when we want to make edits. Using a history-based approach, like you would in most any other CAD system, you'd have to do some sort of feature recognition to dissect the model. That's not the case in Solid Edge with synchronous technology. All we do for edits is click on a face and drag. Simple and intuitive. And notice how things change sensibly. Other faces that are in line with this are moving too, just as if it was an original feature in a history tree. But what if you prefer editing existing dimensions instead? Well sure, just click a face and Solid Edge will provide a dimension for you on the fly, ready for you to edit. Again, notice the intelligence here of all of the holes changing as if part of a pattern feature. And if you want to add your own dimensions, you can do this in 3D, no need for sketchwork. We'll add a dimension for this thickness, and then reduce that to 6mm. Notice the control we have in keeping that top face fixed. One good reason for having a history of features is when we need to reorder rounds. You can see here that the previous designer created 2 rounds in the correct order, but the other 2 are incorrect with the wrong blend. Can we solve that in Solid Edge without a history? Absolutely, just a simple right click to reorder. Done. While we're here, we need to make a change to the size of these rounds. By selecting one of these rounds, Solid Edge can automatically seek out other rounds in the model that are the same size. This way we can save a lot of time by making one edit, not multiple. In some cases though, you may want more than independent dimensions to edit, a good example being holes. Here we can let Solid Edge recognise these circular cuts as holes so that we can go in and change to a specific hole type. Here we want counterbores instead. But what about removing geometry? Well, that's as intuitive as deleting files in Windows. Simply fence select faces, or alternatively choose 1 by 1, and then just press delete. Solid Edge will look after the rest. So you can see how easy it is in Solid Edge to edit non-Solid Edge parts, very flexible. Let's speed through saving this and getting it roughly into our assembly so that we can move on to our next component. And this time we have a sheet metal bracket which was sent to us as a universal CAD file in Parasolid format. We can import this in exactly the same way as we did with the adapter, remember, just a simple file open. Now, not only did we receive the 3D sheet metal file, but also its manufacturing drawing in .dwg format. Wouldn't it be great if we could make use of this drawing to assist us with any edits and also provide tolerance information, all in 3D? Well, check this out. Once we open the DWG inside Solid Edge, we can use a simple tool to grab the information we want, just by fence selecting on screen, and then apply that information to our 3D model. Now you've already seen this steering wheel in action editing 3D geometry, and to keep things consistent, it can also be used for things like this, snapping drawing views into position over the model. So, nice to see the manufacturing intent overlaid in 3D, but wouldn't it be useful if we could control the model with these dimensions? Well, synchronous technology in Solid Edge can do just that. A simple click to attach, and these dimensions are now live, enabling us to make the required changes that we need whilst maintaining this manufacturing intent. For manufacture, we do need a flat pattern, but because this part wasn't created in Solid Edge, how are we supposed to produce this? Go back to the supplier? Nope, not a problem. We can tell Solid Edge to treat this as a true sheet metal part, flanges and all. Now we have an instant and accurate flat pattern. So let's speed through getting that bracket saved and into our multi-CAD assembly, and then finally we'll bring in our drive motor. Now when we bring this in, notice the file name at the bottom of the list on the left. Its prefix is INV. It's from software called Inventor. So like the other components we've been working with, this isn't a solid edge file either. After getting the motor in position, we can see we have a mounting issue. The two flanges don't quite match. Not a problem though, synchronous technology in solid edge allows us to easily grab geometry sizing from one part and use it on another. Sorted. We obviously need to make more room for fastening hardware, so let's make some more quick edits here. First, let's increase the room between the motor and its flange. We'll add 20mm to the throat with a simple drag. And we need to change both parts together to add the required clearance over on the other side. Yes, that's right, a SolidWorks and Inventor part edited at the same time at the assembly level using the same simple push and pull that we used before. So there you have it. Synchronous technology in Solid Edge, allowing you to work with non-solid edge data as if it was solid edge data. Importing just an open, editing just a push, pull or delete, and you can even make use of 2D drawings along the way. Solid Edge, design better.